After watching this video, you should be able to identify form control symbols, understand which form controls can be applied to surfaces and features of size, and be able to interpret tolerance zone shapes for each form control. Let's look at the geometric controls that are classified as form controls. There are 4 form tolerances within the ASME Y14.5 standard: straightness, flatness, circularity, and cylindricity. These are relatively simple in that the feature control frames do not contain datum references, so all we need to interpret is the symbol, tolerance zone size, and in some cases a modifier such as MMC. Let's first look at an example of a straightness tolerance applied to a cylindrical surface. Notice our feature control frame can be applied 2 different ways. Both of these examples specify that the surface variation shall be contained within a 2-dimensional tolerance zone or boundary equal to the amount shown in the feature control frame. Remember, because of rule number 1, when the feature of size is at MMC, perfect form is required. This example shows a straightness tolerance specified for a feature of size. Notice how the feature control frame is assigned to the dimension, not the surface. This tells us that the straightness control is applied to the axis of this cylindrical part. Therefore, the shape of the tolerance zone is a cylinder with a diameter equal to the value given to us in the feature control frame. Notice the diameter symbol modifier shown in the feature control frame. This also tells us that the geometric tolerance is applied to a feature of size. It's important to note here that when the actual size of this part is at its MMC, form error can still be present. This is because rule number 1 can be overridden or ignored when straightness is applied to a feature of size. Similar to a straightness control, flatness can also be applied to a surface or a feature of size. The main difference is that flatness, when applied to a surface, results in a 3-dimensional tolerance zone of 2 parallel planes in which all points of the entire surface of the part must lie. Similarly, when flatness is applied to a feature of size, such as this block, the tolerance zone is also 2 parallel planes, but it applies to the median plane of the part rather than a specific surface.